I hope you guys can hear me okay. Thank you for this introduction. I just wanted to talk about a couple of things today that address the needs of machine tool manufacturers, especially the small or let's say medium-sized ones who think that some of the technology from these days is maybe not for them because it's too difficult, it's probably too big, and that's what they think. So I wanted to sort of burst some of these myths that come with digital transformation. So I belong to this division here of GE, which is called GE Digital. GE has 4 main divisions, actually 5 with GE Digital. And we have this division called manufacturing that concentrates on the products that you guys probably know, like HMI SCADA, MES, etc. So a full set of products from the plant floor to the ERP. And this being said, I wanted to highlight that digital transformation affects the entire life cycle of assets. It's not only about building the machine, but it's also afterwards, once the machine is shipped to the customer, about monitoring and servicing it. So it starts with the design, obviously, but once the machine has taken shape and it is installed, start producing, there's something that a lot of people forget, which is about the amount of data that machines and any asset actually nowadays generates. And this quote comes from a study by the OECD. It's a long study, by the way, probably 500 pages. But one of the things that is interesting is about the amount of data that the manufacturing generates, which is more data than any other sector of the economy. And what does it mean for the companies, whether it's machine tool builders or any company actually that produces widgets or food or whatever? They use their data for analysis. Sometimes they use it for reporting, but another study shows that very little information, or let's say little data, is used for actual decision making or to make, let's say, a good sense of the data. So from left to right, you have different, I would say, scenario saying that the data is maybe not captured, so I cannot have a good picture of what's happening. It's not stored, it's not accessible, etc. So you can read by yourself. And that means that at the end of the journey, only or less than 1% is actually used to make informed decisions. And this is a mind that we have here in many companies, that people are looking at data, but they are not making sense of their data. And I will come back on this when we talk about analysis. So I think it starts with a well-defined data management strategy. When you want to control an asset, a machine, or you want to create a model of it, look at the efficiency, reliability, do some reporting, you need to collect all this kind of data. So manufacturing data, obviously, about the, for example, the tool parameters, some historical data about maintenance, sensor data, which is the actual state of the machine and the health of the machine in terms of running time, downtimes, etc. And if you look at the overall enterprise, you start from something that's pretty small, which is a sensor that has a couple of what we call tags, which is either a physical input or output, or a combination of IOs, let's say, or it could be a simple input, a simple output. And then you combine this into a machine that probably has dozens of tags. Imagine on a line, you have hundreds of tags. And then if you consolidate at the enterprise level, you end up with millions of tags. And the idea is that having this as a mine of information can help improve the behavior and the process that goes across the entire company and specifically across some of the machines. And what I can do with this data is very different depending on what I want to see. I can simply display dashboards, see how they behave, do some analytics, or create what we call a digital twin. A digital twin being sort of a virtual model of my machine. And there's another obstacle that I wanted to highlight when we talk about machines or any kind of asset that's connected. We all have to deal with plants that have a very different level of maturity in Europe. That means that some of the plants have been built like 40, 50 years ago or more, and they have been expanded. They come at a certain stage in 2020. Probably not all of them are digital plants, but some of them are really behind in terms of automation. They just have sensors and someone added automation on the machine, or maybe an HMI SCADA on top. And that means that these two guys cannot really communicate together, and I will have difficulties comparing the performance of this machine with the performance of that machine. And there's another use case which is quite common. If I acquire another plant, that's probably a remote plant, then it might come with a different set of instrumentation, machines, and the level of automation. So that's usually what happens in real life. And one way to solve this problem is to really do some kind of due diligence, look at the maturity model, and try to see how we can put everything up to the same level so we have a good foundation for a digital transformation. And that goes through investment probably, but there are simple things you can do. For example, you can have virtual sensors that represent the state of a machine. So putting in a logical way or logical expression different pieces of data that come from the actual machine to create what we call a virtual sensor. That's one way to solve the problem. And unfortunately, there will be pieces of equipment that you cannot really connect. But in this case, there's probably a way through some of the procedures that you can include the data in the big picture. Otherwise, there will be a gap in the information. So a typical architecture for either the end user or the person who is going to build the machine is this very well-known representation of the ecosystem, let's say the software ecosystem, starting with the industrial automation, basically the plant flow with some embedded automation, whether it's on the machine or outside. And then this level here, which is the manufacturing operations management, that people call sometimes MES, even though MES, manufacturing execution system, is sort of a subset of manufacturing operations system. And then you have the connection to the ERP. So this is the representation of my world, whether I'm making machines or I'm having machines on my plant flow to create something and to produce. So if I look at it from let's say a connectivity perspective and what I see as an end user, this is maybe one plant with machines and local displays and information which is accessible locally. And as a machine manufacturer, I want probably to also have a look at the machines once they are installed. And that has a lot of value for me because I can get information as a subject matter expert, understand if everything is going well, and probably draw some conclusions out of this piece of information, or let's say these different pieces of information. And I can duplicate this as many times as I want, And for the end user, there will be an issue which will be at the same time to see what's happening in the different plants. So down to the plant level with the behavior of the machines, I will maybe not be interested in seeing the behavior of a single machine, but a line, or if I'm a manager, the performance of one plant at a time. So ideally, I would like, as a machine manufacturer, to have also a view that goes across the fleet, not only a view that's let's say a point solution to look at the status of a machine and some sort of very granular view. I want something different. So I want something that I call kind of a hybrid scenario. And the hybrid scenario goes through something that I represented as a cloud, but it doesn't need to be the cloud. It could be something like a hybrid cloud, like we say. So maybe information that resides in servers, which are, when I say servers, that's data repositories that's accessible from anywhere, anytime, so that I can have visibility on everything. And visibility gives me already an advantage. That gives me the ability to compare. When I can see something, I know if it's behaving correctly. I can start building statistics. I'm not talking about analytics or advanced analytics yet, but I can at least have some basic KPIs. So visibility has tremendous value already. And the idea that I can address this anytime, for example, through smartphone or tablets outside maybe the actual plant flow, that also has value. We have proven this in some studies in the US that mobile operators are more efficient than operators that stay behind their screen. And the same applies for someone like this subject matter expert who works for the machine manufacturer. So basically, talking about consolidating the data, that means that I also have a single source of truth, which has also tremendous value. Cross-installation visibility, as I said, gives basic analysis, and anywhere, anytime, on any device. That means that I have data I can trust. I have data I can use and process for something else. And there is more, by the way, when you talk about such a deployment. You can look at the fleets and look at different geographies. Geographies doesn't mean that does not mean that they are on the other side of the planet, but it could just be a few miles away or on the other side of the border. And we have customers who have evaluated the impact of different parameters, such as the harsh environment, tropical, so that doesn't really apply in Germany, but the influence of raw material quality, if people are using different grades of material, and that has an impact on the life of the machine or the behavior of the machine. Also, if people are following the procedures, if they are doing the right thing for the machine in terms of operations, but also maintenance. So I will see that for example, two machines which should be behaving the same way, I have a difference. And that's a conversation that's a good conversation that I can have with the end customer, assuming that the end customer will also have the same information. We can have an informed, let's say, conversation about what's happening and see if the issue comes really from the machine. Maybe it comes just from the fact that people are not using the machine the right way, and that happens all the time. You know better than me. So let's talk about the next step, which is building a digital twin for my machine. So we move from data to information from analytics. When you have data that's interpreted, that's in context, if I can do comparisons, for example, what we call center lining, comparing the performance of different machines in different environments, the extra mile would be to run some analytics on this data and create what we call a digital twin. And it starts with obviously preparing the data, visualizing, creating a model, and what we call knowledge extraction. So we have some AI behind this, so artificial intelligence. And the idea is to create an analytic solution that can be used online. So there are two steps here, the way we see it, which is that first you create a model, and the model is run together with the actual machine. So it allows you to see if there is an issue, and once the issue is fixed, then you can do this on a continuous basis, and that means that you will end up optimizing the machine because you will see deviations. And the idea behind advanced analytics is not rocket science. It's just about making sure that there's a system, that's a computer system, that can identify issues that the human eye cannot see. And there's definitely no way that anyone, like even a process engineer who knows the machine, can identify correlations between parameters which are at first sight not connected. So that's the idea behind advanced analytics. And my point, and why we're talking to you, and we talk about medium size or even small size machine manufacturers, is because this is not something that's only for the big companies, big machines, etc. That's true that when we began using this thing, especially using the online monitoring, a lot of companies, including us, have applied this to like big assets, turbines or jet engines, etc. But now you can run this on a machine. You can run this, I don't know, a small piece of equipment. We have people use it on furnaces. So a lot of different people use this on, it's because it's the same kind of algorithm and the same requirements. Basically, you take data, you create a model, and then you run the model against the actual asset, whether it's a machine that's done for cutting or let's say something more complicated and more sophisticated. So it doesn't matter. The algorithms behind will be the same. So there is a framework that I wanted to share with you, which was created by Gartner and also LNS, if you know LNS, which is an analyst company, which I think is really interesting and shows some kind of a maturity model. It starts with the descriptive. So descriptive is basically, I can see what happened. I know that something happened and the machine stopped. Okay, it's descriptive. And then I have a diagnostic, which is why did it happen? And that's much better because I know that if this part that failed, I can fix it, and then the machine will maybe break, but at least I have fixed the problem. And then there is the predictive aspect, which is what will happen. The system will say, okay, there is a 50% chance that this will happen in the future, and the machine will break, or there is a 30% chance that this will happen. So it will sort of prioritize the chance that this reason 1, reason 2, reason 3 will occur and create an issue. And that's already a big step forward, because that means that I can predict what's happening. This is basically predictive maintenance, what people are doing in the APM world, so asset performance management world. And there is the last one, and the most interesting one, which is being prescriptive. So what action to take in order to make sure that the machine will stay on? I can do some preventive maintenance, I can do some preventive work so that I will avoid the machine to fail. And that's the system will tell me what I have to do. So there are 4 different grades of something that I call my maturity model, basically from information to optimization of the entire machine fleet, or let's say a set of machines. And that can be broken down into 5 steps, which is, if you look at the previous slide, it's slightly different from what I had, because we added one step here, which is about simulation. Actually, this one is more tactical, let's put it this way. Imagine I have a process, whether it's discrete or continuous, whatever, it applies to all the processes. The simulation is my famous digital twin I was talking about. That comes with the what if simulations, and that allows me to create sort of a digital model of my machine. So the first time I will run this model, I will probably end up with optimization, which is great. Optimization always help. And the issue is that if the machine performs at peak performance, what I want to do is make sure that 6 months after, or even 3 months, the machine will perform the same. So I will have optimal set points, optimal everything, all the way through the life of the machine. Even if there are deviations, I should be within certain quality criteria. So that's the monitoring piece that will say, okay, by the way, the deviation is coming, so it will give you early warnings and reduce the amount of downtime waste. And then there's the prediction that I mentioned that will allow much more, or let's say much deeper dive into the data and get, let's say, the actions for you to improve quality, etc. And the analysis is about root cause identification. So that's something that I have to do on a regular basis, like I said. And important thing is continuous improvement. I think a lot of people talk about lean these days. So if you've been in this business for a while, lean was very popular, like in the late 90s, beginning of the 2000s. And for some reason, I see a lot of people going back to lean and Kaizen and continuous improvement. And we believe that digital transformation is also a way, if we apply it right, to enable this continuous improvement, because you can find the root causes of issues and you can really make these small quality increments or tune your machine so that nothing happens, and you improve the quality, you improve the performance and the stability of the process. So that's a really interesting framework as it is. So if you consider before and after, having digitally transform, let's say, the way I look at my machines, that's a very, very different world I'm describing. So from a single asset view, point-to-point solution, I can view the fleet. So instead of checking what's happening, I can do some monitoring. Instead of a status, I can look at something which is about uptime, downtime, with history, etc. Performance to target, of course, but I can analyze the performance again with historical data, share this with my peers, and understand if something is going wrong. And instead of custom access, which is what many machine manufacturers that I know do, so they have some kind of homemade access. If I can use a standard communication device, whether it's cloud or not, by the way, it could be in the cloud, but let's say communication way, or let's say an easy way to communicate, with my machines, that will help. So I'm not an IT person. I want to concentrate on what I know best, which is not about putting together IT tools. And about acknowledging issues, diagnosing what's happening afterwards. Interpret, and instead of, let's say, finding root causes instead of interpreting. The system will tell me why this thing happened instead of me trying to understand what's going on, which is also important when you talking to the end user, because of what we consider as being a knowledge gap these days. We all have issues with plant personnel which are not trained properly. That's not only in Europe, that's the case everywhere. It's the case in the US. And a lot of people are going to retire. I was talking to someone from Boeing a while ago, and they were saying that something like 30% of the operators and engineers are going to retire in the next 5 years. So we are facing some kind of a knowledge gap. So if the machine can tell me and find the root causes for me and help me in the diagnostic, then that has also tremendous value. And last but not least, there is something which is about security, security by design instead of secured by IT. Securing a system is something we can do. Of course, we've been doing this for many years and it's getting better and better. But if you're using a solution that's secured by design, then again, that will save you time and money. So finally, being reactive, being preventive instead of being reactive. That's the conclusion of this slide and the takeaway. So digital transformation as a competitive advantage. Yes, we believe that there are a lot of opportunities for what you call software-defined everything and data as a revenue generator. Again, data that's for the moment is not being used, that's wasted, whether it's logged or not logged, available, not available. But having this data allows for a new business model, because this is something that you can sell at some point because of the service that it provides and the huge amount of money that the customer can save using this kind of approach. And then there is a speed of change. Being able to do this in a few days or months instead of in the past doing this over years or over a long period of time, using, like I said here, an hybrid cloud platform that's scalable, and that's important. Scalable meaning that I can apply it on a few machines, and the same solution that I apply in a few machines can scale big to thousands of machines if I need. I don't have to reinvent the wheel if my application scales or if I have more machines that I need to watch and I'm not being stuck by the software. And last but not least, this is something you probably have seen somewhere else, but it's very true. It's building on the current IT and OT investments and assets. So conversions of the IT world and the OT world, leveraging some of the technologies that people have applied for many years, actually, in the IT world, and leveraging these technologies to make sure that my OT systems are performing and I can see what I want and making the most of my assets. So that's basically the way we see this digital transformation applied to the manufacturing world. There will be next week a live demo webinar that will talk more specifically about the business intelligence side of it. So basically the visualization and how you can hook all this data into an environment and what the benefits are. So you will get the link later on, but just for you to know as a follow-up to this particular webinar. And that's about it, Torsten. I know it's a bit brief. I tried to cover as much ground as I could, but if you have more questions, I think we can open the poll for questions.
Yes, thank you, Bernard. That was an interesting presentation. I have no questions from the audience here at the moment, but maybe we can give the audience a last chance to write down a question. Because in the meantime, I have one question or remark to make. As machine tool manufacturers, we have the situation that many of our sold machines are very, very durable. So that means that there are many machines out in the field being 10, 20, or even 30 years or older. And of course, these machines do mostly not have modern sensors integrated, and they might even be difficult to integrate. And why I'm saying this, I'm just wondering what we can do to integrate these older machines also in such a modern approach that you presented. Because
yeah, no, I think that's a very good question. That's kind of a challenge that we have every day, because some of these machines have very little automation embedded. And for some of them that were built, like I would say 20 years ago, They do have, for example, a PLC installed with a communication port, but sometimes the communication port is very old, and the communication port is blocked for many of them. That's my own experience with some customers, so they cannot connect to the machine. So there are different ways. It's not a one size fits all, but there are different ways of solving the problem. I must say that if there is absolutely no way to record any automated data from the machine, it's probably worth looking at the machine itself, see if the investment, or let's say, you have to change the machine or just live with it, and maybe add this in some kind of manual process where you can probably integrate the data into the overall picture. If you want, for example, to calculate an OEE on the line, and you absolutely want to include the efficiency of this particular machine. For the rest, there are some other tricks you can play. That would be a bit technical if I had to go inside the different options. But for example, virtual sensors that I mentioned, that's an option. If you have measurement points on the machine, you can always create, let's say, add some, let's say, electronic box on it and record some data. I give you a simple example. There is we sell a version of our historian software that is very small, that can fit on a small electronic box like a Raspberry, and it runs under Linux, and that can be used plugged on the machine to connect to a few sensors and get the key performance indicators for this machine. So what I'm saying is that there are ways to connect these machines, not necessarily, you don't necessarily have to spend millions. And for the rest, I think you have to make sure that, I'm not talking as GE here, but you have to make sure that connectivity is your priority. And if you look at the standards for digital transformation, Industry 4.0, let's say, there are standards that are emerging, like OPC UA, that has been emerging for a while actually, and it's all about interoperability. So making sure that all the machines and the investments you make your equipment interoperable with the rest of the customer's application and with the rest of your own applications. I think that's one of the key takeaways from this analysis when you look at the existing plants. But that's true. That's an issue we have every day in Europe because of the I would say the install base that's pretty old in some countries, everywhere actually in Europe.
Yes, thank you. I'm pretty sure new machines sold will be sold also with the new sensors and communication protocol possibilities on board. But on the other hand, they will also going to last many, many years, maybe tenth of years. And the IT world and the sensors technology was really developing fast in the last years. Yes.
Yeah, so I think that's something that people expect from the OT vendors. So basically automation and industrial software and hardware vendors. We don't sell hardware, by the way, so I'm speaking on behalf of the hardware vendors, but there is a request from all of our customers to have long support. So our products all have long lives. I worked for other automation companies, including a big German one in the past. There is sometimes we get requests for like 15, 20 years support for software, for hardware. And we know there are ways to do this, right? So that's not something uncommon. And with the technologies we have, we can always provide bridges so that if you have an investment that's a heavy investment in a machine, you can make sure that you will be still be able to use your machine for a long period of time. So I'm not too worried about this because I think that's part of the design for all the hardware and software manufacturers. We're not in the IT world where you have let's say a piece of software, a piece of hardware that's not compatible for some reason, and then you throw it away. You lose basically your investment. But another point, by the way, is that if you use the hybrid cloud and some solutions which are sort of between the cloud and in terms of software, I'm not talking about hardware, but in terms of software, the hybrid cloud will solve the problem because everything that's above the cloud that's managed by the cloud platform, let's say, automatically comes with updated OS, updated versions of the software, etc. So you don't have to worry about it. That's not your problem anymore. It's like running an instance of I don't know, Salesforce or OSAP. You never really are interested in what operating system they run, right? You don't really care. It's just the service. So it's the same with industrial software, I think.
Okay, thank you. We have no questions from the audience.
I see a question from Mohammed. Is there a potential capability?
Now I see it also. Yes, one moment. Is there a potential capability to use the interface to update the software in future for newer systems?
Yeah, so yeah, that's quite technical as a question, but there's ways to update the software itself without actually going to the plant or yeah, we already do this for some applications. So the answer is yes, and that's more prevalent these days because of the pandemic situation. Just to give an anecdote, once we discovered that a lot of people, a lot of countries had decided a lockdown. Now most of the countries have lifted the lockdown, by the way, but we've seen an increasing interest for remote monitoring, for anything in our software portfolio that allows to connect to the plant from home, from a tablet, from a smartphone. And we even have for a customer free licenses to help them when they could not travel easily to their site. So that's something, whether there is a pandemic or not, that's something that's a definite trend, and that all the manufacturers are working on, including us. We've started to deliver mobile solutions, let's say, for the industry over 10 years ago, and I think now it's well accepted everywhere.
Okay, thank you. We are already a bit over time, I think, so we have come to the last words. Thank you again to GE Digital and Dr. Bernard Cubizol. The attendees can find a participation certificate in the webinar planning tool for download if they have interest in that. Okay, goodbye, Bernard.
Thank you very much. Or thank you. Have a good day.
Yes, you also. Bye-bye.